My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 550. In this lecture, we will try to understand vanishing gradient problem. In 1980s and 1990s, in early 2000s, one of the biggest problem with the neural networks has been the problem of vanishing gradient. This is probably one of the most important reasons why people lost interest in neural networks in the late 90s and early 2000. This is not only the reason, but one of the important reasons. All of your FIJs, isn't it? What is your FIJs? Just see this one: F11, F12, F13, F21, F22, F31. All FIJs. People typically tried FIJs. People typically tried sigmoid function, isn't it? Sigmoid units as your activation units. All your FIJs are sigmoid functions. There is one major problem with sigmoid, which is also same problem with tan h, isn't it? The most popular activation functions that you had in FIJs are sigmoid. Let me explain the problem. Suppose if you want to update, let me say, if you want to update W111, to update this weight, how can I update? W111 new equal to, yes, W11 old minus, what is this? Minus eta into dou L by dou W1 with dou W11, isn't it? So the derivative of L, what is this? This is derivative of L with respect to W11. Yes, this W11 impacts O11. That is important. W11 impacts O11. O11 impacts O21. Also O22. Isn't it? This I already discussed this formula in my previous lectures. Dou L by dou W11 equal to. I request all of you just refer my previous lectures so that you can understand this particular formula, because we have two paths here. Why am I writing this one? Here I have two paths. Because of these two paths, I am getting these values. Which values? This value and R. R means plus. Therefore, as you have two paths, you are getting two values. So, if you notice in this whole derivative, let's look at O31 is an output of your, what is O31? O31 is an output of your function F31. O31 equal to F31 of, here I will get some input. Here I will get some input. F31 will take that input and it will give output O31, isn't it? Yes. Therefore, what can I write? So, derivative of O31 with respect to O21. What is that derivative of O31 with respect to O2? This O31 can be written as, how can I write? O31 can be written as F31 of some input, isn't it? Therefore, so derivative of O31 with respect to O21 is nothing but derivative of F31 with respect to O21, because O31 is nothing but output of F31. Isn't it? Remember, each of these functions, the F11, F12, F13, F21, F22, F31, each of these functions are sigmoid functions, which mean these derivatives. Sigmoid function means what? Sigmoid function means whose derivative lies in F31 is sigmoid function. Therefore, as F31 is sigmoid function, whose derivative dou O31 by dou O21 or dou F31 by dou, it lies in between 0 and 1. Not only that, all these derivatives value, all these are sigmoid functions. All these are sigmoid. All are lies between, that may be dou O31 by dou O21, dou O21 by dou 11. dou 1 1 by dou w 1 1, dou 3 1 by dou 2, all these dou 2 2 by dou 1 1, dou 1 1 by dou w 1, all these values are lies in between 0 and 1. Why? Because all these activation functions we are assuming they are just sigmoid function. Now, if you have multiple numbers, if you look at these three numbers, which three numbers? Just let me say like this. Yes. If you look at these numbers, this dou 3 1 by dou 2 1, dou 2 1 by dou 1 1, isn't it? Dou 1 1 by dou w 1 1, isn't it? Now you have three numbers, all of them lies in between 0 and 1. So what happens in such case? Let's focus on first part. First part means what? This part, dou 3 1 by dou 2 1, dou 2 1 by dou 1 1, dou 1 1 by dou w 1 1, this part. As these values lies between 0 and 1, I am assuming dou 3 1 by dou 2 1 is 0.2, dou 2 1 by dou 1 1 is 0.1, dou 1 1 by dou w 1 1 is 0.05, and you are multiplying all of them, isn't it? When you multiply these three numbers, what will you get? If I multiply, I will get 0.001. You get a value much smaller than any of the gradient, isn't it? This 0.001 is smaller than 0.2, smaller than 0.1, smaller than 0.05, isn't it? Yes. Look at this. This is I can say this number is 10 power minus 3, isn't it? It is 10 power minus 3, because you are multiplying numbers which all of them is lies in between 0 and 1, because you are multiplying numbers which are in between 0 and 1. The value that you get will get significantly less than 1. We are using an update equation. What is our update equation? Our update equation is dou w1 w1 of 1 new equal to w1 of 1 old minus eta into dou L by dou w1 1, isn't it? This how can I calculate this dou L by dou w1? This is the formula. Just check it out. This one. This is the formula. How can I calculate this? This is the formula. But here, this one is small, this one is small, this one is small, this one is small. All these numbers are very small. All these partial derivatives are very small, isn't it? Therefore, dou 3 1 by dou 2 1, all these are small. All these values are small. Therefore, dou L by dou w 1 1 is also small. We are adding, this itself is a small value, isn't it? This one is a small value. This one is small value. You are adding two small values. Again, I will get small value, and multiplying with some dou L by dou 3 1, it's a small value. Multiplying with small value, totally this dou L by dou w 1 1 is a small value, isn't it? We are adding these two small values. This value, and this value, the overall derivative becomes very small. That what is that overall derivative? Dou L by dou w 1 1 is very small. So the overall derivative dou L by dou w 1 1 that you have here is small. If this derivative, what is that? Dou L by dou w 1 1 is very small, then w 1 1 new. Let's say dou L. Let me assume like this. Let me say this dou L by dou w 1 1 is 0.01, eta value is 1, and dou w 1 1 old is, let me assume it is some 2.5. Now how can I get? If I calculate, if I substitute all these values, I will get, what will I get here? I will get this 2.499, isn't it? My original value is 2.5. Isn't it? Then what happens in this one? This so w11 new, what is my w11 new is 2.499, which is very close to your old value. Your new weight is very close to old value because your derivative is small, isn't it? What is the reason? This derivative is very small. Why are you why are your derivative small? Because each of these individual derivatives, are small. You are multiplying you are multiplying all these small values. So your what will you get? Dou L by dou W11 is very small. So your new weight W11 new, this one, your new weight W11 new is very close to W11 old, isn't it? Because your dou L by dou W, because this dou L by dou W11 is very small. And why is it small? This is calculated by using this. Why? Because this is small, 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 this value is also small. Therefore it's a product of other derivatives whose value lies in between 0 and 1. Therefore your dou L by dou W11 is small. Because your activation function is sigmoid or tan H, your updating the weight becomes very hard. Updating the weight becomes this is just a 3-layer network, isn't it? Basically, how many layers you have here? You have two hidden layers, isn't it? One input layer and one output layer. Imagine instead of two hidden layers, let's assume you have 10 hidden layers. What happens if you have 10 hidden layers? Let's assume you have 10 hidden layers. Because I have two hidden layers, I am multiplying 3 values, isn't it? For 2 hidden layers, I am multiplying 3 values, isn't it? Imagine if I have 10 hidden layers, I would have 11 such multiplications, is internal multiplications, I can say, isn't it? So the number of multiplications, of derivatives is number of hidden layers plus 1, isn't it? So what I'm just discussing about these multiplications. Which multiplications? These multiplications. Is this multiplication, this multiplication, this multiplication. Of course, here I have another set of multiplication. Here also I have for two hidden layers, for this hidden layer, here I am getting 3 multiplications. Of course, here I have 3 more multiplication, here 1 more. But internally in this part, how many multiplications you will get? Number of multiplications of derivatives is number of hidden layers plus 1 in the internal part. So when I had 2 hidden layers, we are multiplying 3 derivatives. Imagine if I have 10 hidden layers, then I would have to do 11 multiplications, isn't it? If for just 3 multiplications I got very small value, that is, I got a value which is 10 power minus 3. In the simple example, for 10 layers I will get very small value. If this derivative dou L by dou W11 is smaller and smaller, my newer weight and older weight tends to become almost same. Imagine if this derivative is dou L by dou L by dou W11 if this very small, imagine this derivative dou L by dou W11 smaller and smaller, my newer weight and older weight tends to become almost same. Imagine if this derivative is 10 power minus 10. If it is 10 power minus 10, what happens? It will be very small value, isn't it? Then new derivative would have been very small, something like 2.4. If you were dou L by dou W11 value, if it is something like let me say this value, if it is 10 power let me assume it is 10 power minus 10. If it is 10 power minus 10, this value is very small. These two values almost same. Your older value and new value, they are they will be very close. So this problem is called vanishing. This problem is called vanishing gradient problem. Yes, just go through this vanishing gradient part. Why it is occurring, so that I will continue my discussion on vanishing gradient problem in my next lecture also. That is in lecture number 551. Thank you very much.